Now, let's consider the scenario. A student is diligently measuring a table's length, repeating the process 5 times. The measurements, recorded in centimeters, show slight variations. These variations are to be expected in real-world measurements. Now, let's think about the nature of these measurement errors. The problem assumes that these errors are random, meaning they don't consistently skew the results in one direction. It also assumes they follow a Gaussian distribution, which is a common and often valid assumption for random errors. The Gaussian distribution, sometimes called a normal distribution, is characterized by its bell shape. This shape implies that smaller errors are more frequent than larger errors, and errors are symmetrically distributed around the true value. The prompt asks that based on this assumption about errors, which of the subsequent statements are most likely to be true. Now, let's clarify that options is simply indicating a list of choices related to the analysis of the table measurement data. These are the statements that are being examined for correctness, which are A, B, C, and D. Here, the line describes the first option to select from, which states the best estimate of the table's length is 150.1 centimeters. Now, the line describes the second option, which is related to the standard deviation of the measurements. It claims that the standard deviation is approximately 0.25 centimeters. The standard error of the mean estimates the precision with which the sample mean represents the population mean. In this option, it's suggested that the standard error of the mean is approximately 0.11 centimeters. Assuming the measurements follow a Gaussian distribution, approximately 68% of the values are expected to fall within one standard deviation of the mean. This option suggests that, for this particular dataset, that range is approximately 149.85 centimeters to 150.35 centimeters. Now, let's consider the line lists the specific measurements obtained during the experiment, expressed in centimeters. These values are the raw data used for subsequent calculations, such as determining the best estimate, standard deviation, and standard error of the mean. Now, let's look at this line introduces the overall task or question that needs to be addressed. In this context, it involves applying statistical methods to analyze a set of measurements and draw conclusions about the length of a table, considering the inherent uncertainties in the measurement process. Now, let's look at the given measurements of the table's length in centimeters. These values are the raw data for analysis. Now, let's look at the first option. It posits that the best estimate for the table's length is 150.1 centimeters. Remember, the mean is often used as the best estimate in such scenarios. Now, let's examine option B. It suggests the standard deviation is about 0.25 centimeters. Standard deviation is the measure of the spread of the data. Next, consider option C. It estimates the standard error of the mean, SEM, to be around 0.11 centimeters. The standard error tells the precision with which the sample mean estimates the population mean. Now, let's analyze option D. It states that roughly 68% of measurements will fall within a specific range, assuming many repetitions. This relates to the confidence interval linked to one standard deviation in a Gaussian distribution. Now, let's revisit the individual measurements. These are the specific data points that the student obtained for the table's length. Alright, now, let's dive into the Gaussian error analysis problem. Next, let's look at the problem statement. This defines the task at hand. Now, let's explore the options. These are the potential answers to the problem. Let's examine the first statement. It asserts that the best estimate of the table's length is 150.1 centimeters. Keep this in mind as we evaluate the provided solution. Now, let's focus on what the answer options actually are. These are the statements regarding the measurements that you need to evaluate for correctness. The second statement claims that the standard deviation of the measurements is approximately 0.25 centimeters. Remember that standard deviation measures the spread of the data. The third statement suggests that the standard error of the mean is approximately 0.11 centimeters. Note that the standard error of the mean estimates the precision of the sample mean. The final statement predicts that if the student repeats the measurements, approximately 68% of them will fall within the range of 149.85 to 150.35 centimeters. This relates to confidence intervals assuming a Gaussian distribution. Now, let's consider the underlying assumptions. Crucially, The errors are assumed to be random and follow a Gaussian distribution. This is essential for applying the methods of Gaussian error analysis. Here are your task guidelines. Select all statements that are correct based on the data and the assumption of a Gaussian distribution. Next, let's turn to the raw data, the 5 length measurements in centimeters. 150.2, 149.8, 150.1, 150.5, and 149.9 are the values. Now, let's look at the core of the exercise, which presents a scenario of a student performing length measurements and asks to evaluate the correctness of statistical statements based on Gaussian error analysis. The task involves understanding concepts like mean, standard deviation, and standard error to select correct statements from the given options. The assumption of random errors and a Gaussian distribution is key. Alright, let's dive into the setup of the error analysis problem. It introduces a scenario where multiple measurements of a table's length are taken. This provides a practical context for applying statistical concepts related to measurement errors. Here's the data set. 5 measurements of the table's length are provided. These values form the basis for all subsequent calculations. Each measurement is subject to random error, which is a key assumption for applying Gaussian error analysis. These are the specific measured values in centimeters. The variability among these values reflects the presence of random errors. These are used to estimate the best estimate of the table length. The assumption of random errors is crucial because it allows the use of statistical methods to analyze the data. The assumption of Gaussian distribution is critical. In real-world measurement scenarios, errors often follow a normal distribution. Now, let's look at the multiple-choice statements. Each option pertains to a different aspect of the statistical analysis. This option is testing the understanding of how to compute the best estimate of the measurement, and in most cases, it's the mean average of the measurement values. This option checks if the standard deviation calculation and understanding is correct. Standard deviation is a measure of the data's spread. This option evaluates the correctness of the standard error of the mean, SEM, computation. SEM reflects the precision of the sample mean. Now, let's look at confidence interval. This tests the understanding of Gaussian distribution. Now, let's look at the underlying assumptions that are necessary for solving the problem. These assumptions are important to consider in many statistical analyses and modeling that will follow. Now, let's define the goal to find out which statements from the options are actually true. The task is to identify and select all the statements that are statistically correct based on the measurement data and the given assumptions. Now, let's find out what's being asked. This poses a question prompting the selection of correct statements related to the Gaussian distribution and error analysis based on the given measurements of a table's length. This option presents a possible calculation that is meant to be evaluated, concerning the determination of the best estimate for the table's length. This option touches upon the calculation and evaluation of the standard deviation of the length measurements. Standard deviation gives an idea of spread across the length. This part asks to evaluate a claim about the standard error of the mean, SEM. The standard error of the mean, SEM, provides an estimate of how well the sample mean represents the population mean. This presents a claim regarding the distribution of future measurements, assuming a Gaussian distribution, and requires evaluation of its correctness. Alright, the context is the setup for a problem involving Gaussian error analysis applied to a set of measurements. Important assumptions are made to simplify the analysis. These assumptions allow the use of specific statistical methods. The errors in measurements are random. Random errors fluctuate randomly around the true value, without any systematic bias. The random errors are assumed to follow a Gaussian distribution, also known as a normal distribution. This assumption is crucial for applying many statistical tools and tests. Now, let's look at the actual measurements taken, in centimeters. These are the specific length measurements obtained by the student. These values will be used to calculate the best estimate, standard deviation, and standard error of the mean. Here's where the core problem is. It sets the stage for what needs to be determined. Now, let's delve into a problem concerning Gaussian error analysis. A student has measured the length of a table 5 times and has recorded the following data points in centimeters: 150.2, 149.8, 150.1, 150.5, and 149.9. Now, let's consider the multiple choice options provided. Option A suggests that the best estimate for the table's length is 150.1 centimeters. Option B proposes that the standard deviation of the measurements is roughly 0.25 centimeters. Option C posits that the standard error of the mean is about 0.11 centimeters. Remember that SEM measures the precision of the sample mean in estimating the population mean. Option D claims that if the student were to repeat these measurements many times, roughly 68% of them would fall within the range of 149.85 centimeters to 150.35 centimeters. This relates to the concept of a confidence interval within one standard deviation, assuming a Gaussian distribution. Now, let's restate those measurements in centimeters for clarity. Those measurements are 150.2, 149.8, 150.1, 150.5, and 149.9. The goal is to select all statements that are correct based on the provided data and applying the principles of Gaussian error analysis. Now, let's determine what the student needs to do. Now, let's restate the problem to better understand it. Now, let's clarify the context in which data analysis is performed.